Thank you, Dr. Papachristoudis. Let me share my screen. I hope you can see my presentation.
Yes.
Okay.
Okay.
So let me set up this. Okay. So hello, ladies and gentlemen. Thank you for being here with us at this late hour. Given my professional academic area of interest, I would like to provide a different view of our mission, that regarding of the performance of steel structures during the seismic events of February the 6th. We will focus on certain categories of structures, as you can see here in the contents of my presentation, which I will not mention in detail, as we will see them as we go. Before presenting the findings of our missions, I cannot help to mention that my most basic observation was not so much the performance of the steel structures, which was pretty much as expected, but the relative lack of steel structures, even for 10 or 12-story buildings or industrial buildings, which usually are more covered by steel structures. To add to the data provided by the excellent presentation of Professor Erberick, if you allow me a small introduction, you can see in the left chart that although Turkey is making a turn towards reinforced concrete buildings compared to masonry, due to the fact that most new buildings are reinforced concrete ones, the remaining structural types claim only less than 1% from the stock, from the building stock. In these other frames, of course, steel is included, and we can see the same in depending on the number of stories of the buildings. Now, if we see this next slide, we can see in more recent data, there is a break. We can see how these buildings are divided in each category. We can see in the left chart, we can see that for the residential building, concrete is, for the new buildings, concrete is by far the most popular material, with structural steel structures claiming only a mere 0.2%, and as residential buildings comprise 85% of the total buildings, we understand that this is the major share of the market. As expected, things are a little bit better for non-residential buildings, where still seen here with the orange line can be seen claiming 10% of the market of the remaining 15% of the total buildings. By the term non-residential buildings, we include all other uses like commercial, industrial, cultural, administrative, educational, etc. On the upside, we can see that there is a clear trend of the steel structures claiming a bigger part of the market, which could help improve seismic performance in regions like the ones we visited. To that end, we can see what happened in the previous earthquake, like the one in 2003 in Bengal, which hit with a magnitude of 6.4 and resulted in 625 collapses with at least 177 fatalities. 84 of these fatalities were due to the collapse of a dormitory block in a boarding school, while more than 90% of the schools were affected with 4 collapses. Here we can see in this slide one of 21 schools with identical floor plan, which collapsed. Here there is a missing story due to shear failure of the columns. As a result, an innovative pilot modular school was built in this area in 2006, as we can see here on the left. Or more recently, we can see this steel school, which was constructed in Istanbul in a record of 72 days, covering, I don't have it, like 1,600 square meters. So we have discussed about seismic isolation of hospitals, but as it wouldn't be easy to put seismic isolation in most buildings, perhaps some buildings could be considered to have still a solution to achieve better seismic performance. After this small introduction in steel structures in general, let's see the ones we observed during our missions. First of all, we saw roof structures, which were understandably from structural steel. This one is from the municipal market in Urdagi. Although no bracing can be seen in the longitudinal direction, the structure behaved well with no significant damage, which is to be expected for structures which are light like this. I'm not sure why this is not moving. Okay. We observed the permanent deformation seen here, a lateral deformation, but this was probably prior to the event, as rust marks attest. The only damage that we could identify that could be from the earthquake was this surfacing of the anchor at the corner node. You can see here from afar and here in detail, which was probably due to insufficient cover and absence of reinforcing steel. As the structure remained safe and fully functional, it was used to cover tents, which provided civil services, function which was of paramount importance in the regions that were hit. We witnessed a very well organized effort from the Turkish authorities to aid the people that were suffering due to the earthquake. Another example is this outdoor parking in Islahiye, if you excuse my Turkish accent, which also remained fully functional, with the only damage that we could observe coming from falling debris from the adjacent building, as you can see in these two photographs. As I said in the start, we recorded a lot of multi-story buildings, but unfortunately none of them was steel. However, normal practice was to have a steel roof here at the top. So this was a detail that we saw in several buildings in most of the cities that we visited. These structures behaved rather well, especially if they were connected to a concrete part in the center of the floor plan, which could be used for access to the roof. So even in buildings that were heavily damaged, and despite the increased spectral acceleration of the top floor, this structure behaved relatively well. This was even better for such code designed structures. Here you can see more stiff braces and a structure of better quality. Although this building in Gaziantep was probably not hit, it was not hit by the earthquake so hard. Nevertheless, we did observe some failures. In this building in Pazarsek, we saw total collapse of this structure. The building, as you can see, is severely hit by the earthquake, but failure came here mainly due to lack of anchorage and absence of bracing, which would provide maybe alternative stiffness. So this structure, although not critical for the building, could cause serious injuries if it came down from 5 stories above. Here we can see this 2-story building. We can see this top structure is mainly intact, with all the damage coming from mainly from pounding due to the collapse of the neighboring building. Another category of auxiliary structures were steel appendages that were used for other purposes, like this fire escape in this building. We can see once more that falling debris severely damaged this fire escape and probably blocked the alternative route that would be perhaps needed. And if you are thinking, why do we need a fire escape after an earthquake, we can see this building with a light green color in Gulbasi, where, as the speakers before me told, suffered severe deformation, settlement, and permanent inclination, which completely destroyed the fire escape, which would be useful after the submersion of the building in the ground as an alternative exit from the building. We also recorded one case, no more, it wasn't very common, at least in the regions we visited. We recorded the case of a building in Antakya where it was retrofitted with steel frames in the second story. Although the structure did not collapse, we can see that all the plasticity demand concentrated in the second story where the steel members were implemented, and all the infills were completely destroyed. So although the structure did not collapse, the repairing of this structure would be challenging, to say the least. It's probably beyond repair. A different case was this building in Kahramanmaras, which, to the best of my understanding, was suffered damage from the adjacent building that collapsed. By the time we visited, all the damaged sections were removed, and the steel frame was placed in their place in order to restore the building to its previous functionality. So it seems like restoration was in progress. On my last note on buildings, I would like to mention the once picturesque Kurtulus Avenue in Antakya, which probably was the city that suffered the most in February the 6th. There we can see a lot of variation of this special type of building, two-story building with the characteristic projection of the second floor over the ground floor. These buildings of the 20th century, of the early 20th century, consist mainly of masonry or brick outer walls with or without timber elements. And most of their slabs here at the ground, at the top of the ground floor, were reinforced concrete slabs with which were supported by steel I-beams, which also support the cantilever. These structures sustained varying level of damage, from negligible, as we saw before, to total collapse, in which cases you can see the steel members exposed after the collapse of parts of these structures. At the time of our mission, it was not easy to identify clear causes for this versatile behavior, other than possible difference in quality of construction and the unfavorable response of the corner buildings. As you saw, these buildings are in touch with each other, so corner buildings seem to suffer more than the ones between the remaining ones. Given the historic architectural nature of this street, further investigation and the restoration of these buildings would seem necessary. Now, to move on to bridges. Bridges in general were behaved okay. We did not observe any damages other than the activation of the seismic links, the seismic stoppers, and small permanent deformation at the bearings in some cases. This was even better for steel bridges like the ones shown here. These pedestrian arch bridges were fully functional and without any visible damage, as was this railway bridge in Adana. However, we did observe some damage in bridges of Antakya, as would be expected. This pedestrian truss bridge has no significant damage in structural damage. However, it was out of service due to collapse of the facade and the parapets that would keep people safe. So it's in need of refurbishment, but it's not beyond repair. Also, these smaller bridges, they have non-structural damages, also a few buckles in these very slender bases, but nothing that cannot be easily repaired. Here, this bridge with a steel tower, we also have some failures in the facade or the end of the bridge, but nothing very serious. I will close this presentation with a mention on the industrial buildings. I was indeed a little surprised to find out that even this type of buildings was dominated by prefabricated, pre-stressed structures like the one in the picture here before the collapse, here after the collapse. These photos were all taken in the industrial area of Kahran Manmaras, and the critical connection is probably here. The connection between the column and the beam wasn't very well designed or well incorporated, and due to this connection and the lack of robustness, the lack of alternative load routes, we could see whole base of industrial buildings collapsed like the one here. However, we did see some industrial buildings. Most of them behaved quite well. That we did see damage in the non-structural elements like the panels and purlins, but nothing very serious. However, many of these structures were, let's say, built rather based on, we did see several structures that were built rather based on experience rather than design. And in the course of our travels, we did see steel structures collapse. So it should be investigated if these were indeed code-designed or not. Here another one, and the same goes for other industrial facilities. We did record some silos and tanks that were fully operational and without any significant damage. This was from me. I will not bore you with my conclusions, as I have mentioned most of them already. The basic one is that the steel structures should be explored as an alternative to improve seismic behavior in Turkey. And at this point, I would like to thank George Tsiatas, which I'm sure that I saw in the panelist list, who has taken many of the photographs that I just showed you and has a keen eye for steel structures. I would also like to thank all the members and contributors to of this mission for this life-changing experience, and of course all you, ladies and gentlemen, who for your kind attention and patience to be with us at this hour. Without any further delay, I would probably like to present the next speaker of tonight, which, if I'm not mistaken, is Professor Tsopelas from NTUA. Panos, the floor is yours.